Hello, Sam. Nice to have you on the Gelato podcast. How are you doing today, sir?
Hey, Luis. Doing well. Thanks for having me on, man. Doing well today. Yeah, excited to dig into the weeds.
Yep, indeed. So today we will talk about Rise Chain. You guys have been definitely popping up more and more on my feed on X. Actually, I think I first saw you guys last summer. I think what was it last summer? You were presenting at one of the I think Paradigm days in San Francisco, the parallel EVM sort of solution. That there was when Mainnet was, I would say, at the peak hype. So you guys were sort of cooking there a bit, and So can you let us know who are you first of all? We know you're called Sam, but who are you, right? And then also who's Rip.eth, because this guy is also constantly on my timeline these days. Who are the founders, and how did you stumble upon sort of building what you're building now?
Yeah, okay. It's a bit of a long story. So my background's in embedded systems and software engineering. Initially started out in electronics and just migrated to lower level firmware. Spent a lot of time essentially running engineering teams, specifically for a company that did eye tracking that's now in GM vehicles, to make sure you're not falling asleep. That was like a good chunk of my career was doing that. But my first foray in crypto outside of mining while I was at university was I built some HFT strategies on centralized exchanges. So predominantly Bitfinex. At one point, I was about 1% of Bitfinex's volume. I ran that for about 2.5 years. And that was great. I loved it. But I got distracted. I lost my edge and I caught the DeFi bug. So I fell in love with DeFi because it was just this open platform where you could deploy code and that code could be completely permissionless and accept tokens. And I think we still, because the DeFi summer was essentially 5 years ago now, I think we've lost a bit of that love for that openness, and I think we can't forget it because the newcomers to it see that excitement. But what we built, what my mate and I built, was a vault protocol called RoboVault. It was a actively managed delta neutral strategy. It was fairly novel of the time. I think we were the first people to do it, but complex strategy where you deploy assets to a lending market, borrow against it, and hedge it in an AMM. So very involved, actively managed DeFi strategy. And the biggest challenge that we had was that anytime the market would move, and when there were fluctuations, we'd have to land a rebalance transaction. And the purpose for that was to maintain that hedge. If we didn't land that rebalance transaction fast enough, we wouldn't be able to maintain that hedge. And ultimately, that became the Achilles heel of the product. We ended up having to wrap it up because we were just spending way too much money in fees on these rebalance transactions. Some days we'd spend 10 to 20K just on fees trying to rebalance when the market was moving. So how I reflected on that was that we had this product that clearly had market fit. There was demand for it. We were able to add value, but it didn't have product fit, that it just wasn't sustainable. The infrastructure wasn't there. And so after we wrapped that up, I had about 9 months of soul searching and reflected on these two experiences that I built. HFT, I knew what it was like to build in the modern web era. There's just high performance. You can spam transactions. You can hit 200 TPS, which is around what I was doing at the peak. And then coming to crypto, where there's just so many constraints about what you can do, and it just really limits the opportunities. And what I saw in the application domain was just so many builders working around these constraints and coming up with these really ingenious ideas to work around it. And I essentially wanted to flip the script a bit and ask the question if this was possible, if it was possible in the infrastructure layer to offer a experience that matched what you see in the Web 2 landscape. And that was, and I warned you it was a long story, but that's the premise, that we wanted to build infrastructure that maintained the best parts of crypto, so the openness, permissionlessness, censorship resistance, kind of the best parts in Ethereum in particular, while offering that high performance developer experience and infrastructure that Web 2 developers are familiar with. And that's a crux. I might pause there before I dig into where Rise is now, I guess.
Yeah, so I guess it's fair to summarize your story there as you build RoboVault, which, by the way, I heard of. I'm not sure if we talked to you guys at some point back in the day.
We were power user of Gelato and
exactly.
Yeah. We were the top gas burners on both Gelato and Chainlink for like 12 months.
Yeah, like I remember your name, like in some of our business intelligence dashboard. It showed up, like that's why I was ringing a bell. That's funny. I had no idea that you were behind that. So, but you were building a composable product, right? I suppose, like you were leveraging composability on Ethereum, I suppose. And
we were on EVM, we were on Phantom and Avalanche. Just you couldn't build this on Ethereum because it was too slow and expensive.
Yeah, we were actually pretty big on Phantom and even Avalanche back in the day. Makes sense. We had a ton of users there at some point. Essentially, this like product didn't work so well because the infrastructure didn't scale. Costs were too high. So you went back to the drawing board and you said, okay, let's fix the infrastructure part, which also is like probably why you are building like a layer 1 or a based rollup rather. Like based rollup is you building like a layer 2 actually with Rise, right? But it sits somewhere, like I would say, depending on like we can argue about the exact definition, but it's like a based L2 nowadays. You're building your own execution layer essentially. I guess that's the gist of it. And you don't build like a purpose built like roll app CLOB chain or something like this. Is this because you believe in composability as well as a core concept, or?
Yeah, absolutely. I think from my experience in RoboVault, I saw the power of composability. And it's not just from a product standpoint, the fact that you can plug into this product and plug into that product and create a new structured product. It's also the relationships you can build. You can work with other teams and help one another to build things out. So there's just, when you're in an ecosystem that has a lot of thriving developers that work together, because like they share each other's success, and Phantom was a great example of that back in the day. And they've done it again somehow. Sonic's a bit like that now. There's like they've just got a very strong community of builders that do well together. So I think that's part of it. But how I really look at it is that Uniswap doesn't need a strong distribution strategy at the moment, because there are so many applications building on top of it. And if you have an app chain that's very specific, you don't have that option. And to gain that option, you have to build out that infrastructure. Like we're already seeing that with HyperLiquid, the interaction with HyperEVM and Hypecore is like a work in progress. They've got to build the custom precompiles, and they've got to like builder codes and things like that, so the brokers can plug into it. There's just a lot of friction there. But if everything was EVM from day one, you don't have that friction. Anyone can build composability. Someone spins up a CLOB on Rise on day one. Day two, someone can spin up a fully on-chain Athena that has a cash and carry trade that's just credibly neutral and completely permissionless.
So like it seems like your core belief in confidence and competency is like max performance, getting everything, squeezing everything out of the EVM that is humanly possible. I mean, we've heard this story. It's been popularized by Mainnet, of course. You guys were like, I remember like watching one of your early talks, and I was like, wait a second, there's this giant Mainnet. Like what are these guys suddenly doing, and why are they also trying to paralyze the EVM? And now you've been rising, right? Like it's in your name. Originally you guys had a focus on parallel EVM. Is it a similar story to Mainnet, where actually this is less of a focus because you maybe found out that there's not that much to squeeze out there? Like, are you also building your own custom DBs, this and that? I know recently there's a whole other topic we can talk about in terms of based sequencing, but let's start with the virtual machine architecture first. Like, why do you think, or like, what do you think makes Rise unique in terms of, being in the category of high performance chains, which is getting a bit crowded nowadays, right? But yeah, where do you stand out?
Yeah, I'll give the brass tacks. The dirty little secret of parallel EVM products, essentially, that it had, the narrative had a bit of hype 12 or 18 months ago, is that people went out and built these parallel EVM stacks. We built PVM, which with the hope to essentially 10x the performance. And we found that, yes, you can 10x the performance for highly parallelizable workloads, but you can't 10x the performance for workloads that need sequential actions, which are, and those kind of transactions are the transactions that require the most demand. And so what I mean by that is, if you have, say, an AMM, or even if it's like a CLOB or order book, every single trade that happens on that order book has to happen sequentially. So you can't parallelize that. You can parallelize everything else, so you can speed up all the other auxiliary things, so that you can have multiple apps running that don't have interoperability, or like don't have cross-state access. That's fine. But what typically happens in an ecosystem is you have one or two apps that use up like 95% of the block space. That's an exaggeration, but as said, like it's in that order of magnitude. So we built it. We were able to get massive high gas per second, many gigagas with this parallel EVM workload. We wrote these benchmarks, and it was really cool tech. But then we plugged it into the rest of the stack, started to tune every knob, and we just found bottleneck after bottleneck after bottleneck in other spots in the stack. And so we shifted. We spent our time working on each of these individual bottlenecks, and these bottlenecks just aren't as sexy to talk about. So you don't find them in the mindshare. Things like the mempool, for instance, just to actually organize and orchestrate a mempool is a big bottleneck. Things like the interaction between the consensus layer and the execution layer, which is there's a middle an interface called the engine API. That's a massive bottleneck. Things like this. So it was really like knocking down dominoes of bottlenecks, and each time we knocked down a bottleneck, we'd open it up another bottleneck, and it's kind of like playing whack-a-mole. And we did this for 12 months, and we went from a stable 1K TPS to now we've had blocks on our testnet that have reached 50K TPS, and our goal is to hit 100K steady state. There's a big difference between being able to handle spikes and steady state TPS. But yeah, that's, if we can hit 100K TPS steady states and being able to handle spikes, that's gonna be enough capacity to last probably the next 3 or 5 years. That's broadly speaking how we think about it.
Okay, so essentially, to summarize your point, and by the way, sorry, listeners, if the microphone transmission wasn't perfect there. I think we just fixed it, so the rest of the pod should be better again in terms of audio. But yeah, sounds better now. So you were just saying that essentially you found out that parallel EVM was a bit overhyped, and you found other ways to squeeze out the performance, is basically the gist of it, right?
That's the crux of it. Yeah, PVM, we got about between 2 and 6x, 6 on good times, but found a lot more optimizations elsewhere in the stack.
And this is mostly due to application design, right? Like, I suppose if you want to leverage parallelism, you start from the application design and not from the platform, like base layer design.
That's right. If you want to build an application that can support highly parallelizable state, then parallel EVM is perfect for that. You can scale quite a bit, but history tells us that most applications require sequential execution. You have this global state that everyone wants to interact with, and that becomes the hot state everyone wants to touch.
Yes, especially it seems like in trading and finance, sequentialism is very key.
That's right.
As a former HFT trader, I'm sure you love sequentialism. Getting in first, I suppose is important. But all right, cool. So we started on this parallel EVM narrative, not just narrative. I mean, you guys were actually building. I think since then, one of the core things that sets you apart is that you are very focused on based sequencing. So where have you landed with Rise Chain in your stack on base sequencing? I also know that you guys are using, I think, Celestia, right, for DA, which is because Ethereum doesn't have enough bandwidth for the sort of multiple gigagas throughput that you want to have, I suppose. So where have you landed on the base sequencing design, and how do you square this mix of Ethereum and Celestia in this design?
Yeah, look, I think a good question to answer is the why based, why we went down the base route when we're super focused on performance. We, like I said at the beginning, we wanted, our mission was to build a stack that maintained the best parts of Ethereum or crypto values while delivering on performance. And so to solve that first part, we explored our options and we looked at what was available to us. And that was back when shared sequencing had some potential. That's essentially come and gone. So to decentralize your infrastructure, there's not many options out there outside of building your own node, your own validator network, essentially. And that wasn't something that we wanted to do because we could see there was the best validator network was the chain that we were already quite close to, which is Ethereum. So it really came down to a very pragmatic lens. We're able to bring ourselves closer to Ethereum, which has benefits for network effects. You're able to unlock synchronous composability with Ethereum, and you're also able to unlock synchronous composability with other based apps. That's the vision. Okay, so that's the pitch of base sequencing. Composability, credible neutrality, that's going to be the ecosystem that wins out. Funds are going to flow seamlessly. You're not going to have all these liquidity pools. It's going to be fantastic. That was a vision 12 months ago, or probably 18 months ago. And people have been working towards this. There's a bunch of teams. Tycho is essentially leading the way, but there's a wealth of teams, and Justin Drake did a lot of work to push this forward. But it hasn't happened as fast as everyone had hoped. It's actually been slower than people had hoped, and it's because there's just a lot of challenges to pulling this off. Setting up a validator network that can offer preconfirmations to base rollups is challenging. Getting enough base rollups to work together on essentially trusting each other's security solution so you can unlock some of these value add features like composability is just a difficult task. So where we've landed is we have a 3-phase rollout, which is we've got an article that's going out next week on this. Phase 1 will be base preconfirmations with a centralized sequencer. So this will be where users we've got a technology called shreds, which is how we execute and provide really low latency transactions. These shreds can optionally have a signed preconfirmation. And what users can do with that is if the sequencer doesn't submit the transaction as was promised onto the L1 when it does the next submission or next settlement, they can slash the L1 validator that essentially signed that preconfirmation. So add security to users. They get this pre-confirmation. They get security that there's economic security tied behind the transactions, and we also benefit from a distributed network. So that's phase one. Phase two is when you introduce rotating sequences. So you rotate these base sequences, but it'll be whitelisted. And then phase three is when we do fully permissionless. That's the high level plan we're at the moment. But it's very iterative, and we'll do things and then see what other teams are doing, see who we can work with, because the more teams that join the based ecosystem, the better it's going to be for us, for the network effects. And I think the Ethereum leadership is cluing on to base sequencing being a high potential source of adoption and revenue for Ethereum.
Cool. So for phase one, you mentioned that it's already based pre-confirmations, right?
With a centralized sequencer.
Yes. So help me unpack and understand base pre-confirmations a little bit, because there have been various designs like MEV commit and chain bound and so on, and like some of these designs, like I said, were more like pre-maybes than pre-confirmations. So how is your, like, first of all, you have decided to have your own design instead of going for like an open spec? I suppose these projects all had their flaws. Maybe they were too early and they probably figured that it's better to have your own design, or are you actually using like an open spec? Like I've heard talks about gateways. We talked a bunch with the Gattaca team already. Very excited about what they're building.
Kubi and the Gelato team and have done a great job. They're essentially leading the way alongside Fabric as like a collective of teams working together. So yeah, we will be using a similar technology. They have a design where they use the engine API and run a sidecar. We won't be doing that. We'll have to do some custom code ourselves, but the API spec will be exactly the same. So we will be using what's called the constraints API, which was developed by the predecessor to Fabric, which was essentially just a preconfirmations working group. And then on the commitments API, we'll also be using a similar standard. And there's an URC universal registry contract that we also plan to use. So we're essentially following the leaders in the base sequencing evolution. We're not looking to innovate and like lead the charge here. We're looking to be a participant in this thriving ecosystem.
Okay, so there's this notion of API interface compatibility. What is who is the standardization for? Is this ultimately for the L1 validators to be able to?
There's a lot of people in the stack, and like this is why it's so hard to build and coordinate. So you've got the constraints API is an API that's built on, and it's essentially an extension of the MEV Boost API. And it allows relays to be the middleman for validators to delegate rights to a gateway. And so when you're delegating rights to a gateway, you're saying that I trust this gateway to give out commitments. And then that gateway can give out commitments to either users or directly to a base sequencer. It really depends on the particular stack. But yeah, so you've got the validator, relay, you've got the builders as well, which need to look at these, need to understand these commitments, otherwise they can't participate in building that particular block. You have the gateways and then the base sequences themselves, which often are the gateway, but that isn't the case in some designs. Oh, and sorry, on top of that, you've got like the wallets that need to be able to process these preconfirmations. It's a little bit messy, and that's one of the challenges that we're trying to work through.
So with your preconfirmations, the goal is for them not just to be based and to have a like why be based. I suppose the idea is to eventually go away from centralized sequencing, like you mentioned, and eventually have a decentralized sequencing set. This would be a set of opted-in L1 validators, right, from Ethereum, essentially.
Yeah, so it'll be opt-in L1 validators, and they can sequencer blocks themselves, or they can delegate rights to a builder or a gateway. The terminology is kind of in flux, but this looks very much like Ethereum L1 builders today. You have a handful of very large builders that are super sophisticated with complex technology to essentially lead the market. That's what I anticipate will happen, that you'll have a critical mass of L1 validators that use a sidecar to participate, and they might delegate to the builders that they want to work with. And then it's actually these builders that build all of the blocks. And a question we get asked commonly about base sequencing and low latency is, how do you have a distributed network of builders or like validators in a sense, and still offer low latency? And the way we do that is by ensuring that the builders are within a tight geographic region. So we're not going to build a system where we have base builders all around the world. They're going to be in a location where there's a high density of countries, and the hope is to be able to reduce the essentially what HyperLiquid's doing, but we're doing it for a based decentralized L2. All
right. So I suppose the end game of research there is like multiple concurrent proposers or something like this, or like, I mean, that's more like proposers, builders in Solana. I don't know. But are you even interested to venture there, or do you say no? Like a degree of geographic centralization is fine for what you're trying to achieve.
So there is, and I think what you're alluding to is that MCP has the potential to reduce latency while still offering a like global distributed validator set. That is true, but only for inclusion. So you can get a very, very fast confirmation that your transaction will be included in the block, but you don't know where in the block it's going to be included. So for things like HFT, when you are submitting a trade and you need to know if that trade was successful or what price, if it's a market order you landed, or if you have a limit order that order was executed. You don't know that until the block is finished. And so I think this is like the Achilles heel in MCP, in my opinion. And I've asked this question quite a bit to the Solana camp and haven't got a clear answer on it. But MCP is great for fast inclusion confirmations, which is great for cancel priority. So you can cancel cancel your orders. You know what's in the block, you know what's at the front of the block if you have cancel priority, so that's great. But it doesn't solve low latency for a distributed network. I'm of the opinion you can't solve it. The only way to solve it is to have like geographic concentration of the validators or builders to be in a tight geographic region.
All right, that's essentially that is a big counter to the Solana vision, Toli's vision, I suppose, of everybody around the world should have the same latency in a way. And I always thought about inclusion as, it's interesting that you mentioned that the use case is cancellations, but ultimately always, like you mentioned the shared sequencing networks, and they were originally all about atomic inclusion. I was like, wait, that's like maybe 10% of the usefulness. Like what you want is atomic execution, right? If you're a market maker or someone like that. So you can only get that by essentially, knowing what the block build is like.
Look, I'm an engineer, not a researcher. So, and my research team has looked into this, and this is a conclusion we've drawn. I'd love for someone to tell me otherwise, but I'm fairly confident that this is the case. And I've asked Toli directly on Twitter. He hasn't got back to me, but I'd love to know if this thinking is accurate.
Yeah, interesting, cool. So you're basically embracing. You're embracing your HFT background, and you say like HFT is here to stay, and HFT comes with co-location, and in this case, so in this design, you would try to co-locate with builders, but the reason to have base sequencing and why it's still interesting, and not just for like the nuance of cancellations. Is essentially like for the escape hatch of the Rise rollup, like and you can always get if you want to leave the chain, if you want to withdraw from the chain, you can definitely get your funds included because it's using Ethereum for sequencing.
Yeah, so you get that even without having distributed sequences. So like this is possible with a centralized sequencer that you always have an escape hatch. But how I see that as a liveness failure. Because if you're offering a service where you have 100K TPS and really low latency, and then you stop offering that it just essentially turns off, and the only way you can exit is through using 12-second confirmations on Ethereum, I consider that just like a catastrophic liveness failure. So what this actually does provide is liveness and censorship resistance because these sequences are rotating. So yes, we have escape hatches as like the worst case, like plan D, but we have a plan B. If say we have 4 builders that are rotating, or say 10 builders, even better, in a region, until those builders get pulled out because the government in that particular region doesn't want them building blocks for Rise. We then have another 8, and there's going to be market opportunity for someone else to jump in and fill that gap. So I think it provides a higher level of liveness and censorship resistance.
All right, but ultimately in your design, the builder has a power like you don't. Do you have force inclusions via like can you sort of force transactions into the final block? Yes,
yeah,
right.
You can still through Ethereum, like directly on Ethereum. There's forced inclusions.
Yes, and I think I think, I mean, you're right, obviously, that nowadays we already have escape hatches. I think Arbitrum is pretty far in that regard, but usually they're like more than 24 hours or even longer. Would you say that being based uniquely enables you to already have the sort of force inclusion latency be much less than that?
Unfortunately not.
All right.
I wish I could say yes. But the thing that unlocks that is ZK proof. So we're still optimistic. We have to be optimistic to support the performance we want to support right now, at the cost we want to support it. However, once ZK becomes performant enough, we will migrate. But yeah, it's very much ZK that brings that that window down to as long as it takes for the ZK proof.
Yeah, I would say yes, like the ZK proof is, you need that for the state update, but ultimately if you are already included in the rollups blogs, then like you sort of have almost like an inclusion guarantee, right? Like you know that you will be able to, like, but yes, you don't have the funds available. So
actually, but you can, they're safe essentially for during that window. So you've got confirmation on it, you just can't access it.
Yeah, but the sort of actually, how does that work on Rise with Celestia and Ethereum? Because technically your transactions are on Celestia, right? So the like that's your DA. Like, do you have a commit, like a blob stream type situation on Ethereum, or?
That's a plan, is that we'll use Celestia's blob stream so that we can offer that.
Yeah,
I'd say and this is not my area of expertise, so I don't want to speak to this like I'm an expert. It's our research team is who's put the time into this, but that's essentially where we landed when doing the exploration of different DAs. That second to ETH DA, the next best is Celestia plus blob streams to provide security. So that's the direction we're going.
All right. So in a way, actually, Celestia is your base sequencer of sorts, right?
There's one way to look at it. It's Ethereum validators are the ones that will be in charge of sequencing our transactions, but Celestia will be in charge of the DA. They're orthogonal to one another. Where they're not orthogonal is for composability with adjacent rollups. So we won't be able to be interoperable with a base rollup that's using Ethereum DA, for instance.
Mm-hmm. Yeah. So I suppose Celestia is like the sequencer, but the sequence is only finalized or proposed when the blob stream hits like Ethereum. Like that's basically how you wrote your full node, right? Like when you sync the Rise chain, you need the data on Celestia. That's the precursor, but it has to be anchored via blob stream on Ethereum, right?
Yeah, that's bang on.
All right, gotcha. Cool, nice. Actually, talking about shared sequencers and based rollups, how much value do you think is there for the other projects that you can connect to that are based versus just connecting to Ethereum itself, like the L1? Where's is there like a power law where you get 90% of the benefits just from having, shared sequencing with Ethereum itself?
Honestly, no one has an answer to this question yet. And it really depends on how strong the Ethereum-based ecosystem becomes and how much interoperability there are within apps in that ecosystem. There's also, I'm not naive to the question of, is synchronous actually all that valuable, or does asynchronous composability provide like the 95% of the use cases? That's an open question that we still don't know. We're not building our product around that concept. That's a value add from base sequencing, but base sequencing has other benefits that justify us to use it. So yeah, exactly. I think that in summary, the L1, L2 composability is great in theory, but in practice, it's likely you'll only be able to do those synchronous transactions once every 32 blocks initially, because that's how big an epoch is. The way the base sequencing designs work is that you submit every 32 blocks because you have a validator that registers to participate in the look ahead. So yeah, I honestly, this is a question that we debate internally quite a bit, and we're unsure. I'm very unsure about it.
Well, I can tell you my stance. Like I'm very bullish on base sequencing, but not for the composability aspect. I'm actually quite bearish on the synchronous composability, and I usually debate like, because Justin is like the opposite. Like he seems to be most bullish on the composable synchronous composability aspect. But for me, base sequencing, the reason I'm pilled and have been pilled for a long time is just this idea of, you know, like decentralized sequencing essentially, and the base layer being the best, and the A layer being the best sequencers that you can choose, right? Like we mentioned, the origins of Espresso and Astria. I think both projects probably seeded working on on shared decentralized sequencing. I don't know if they did or not, but yeah, it seems like yeah, you know, like a DA layer like Ethereum or Celestia are definitely the best decentralized sequencers, and that's why base is already cool.
Absolutely, there's something amazing about the fact that Ethereum will and all L1s will essentially run forever as long as there's enough economic value, and that their security model holds out. And if we can bring that to L2s, I think that's going to be a net value add to the world.
So last very technical question, and I mean our audience, I think they are.
We're going in the weeds, so I feel sorry for your audience.
No, it's like
I appreciate them, but they're still around.
You know, if you're around at this point, you probably love the tech. You're in it for the tech as well, right? Like, so you'll want more. Yeah. So one more technical like question then. I always look at base sequencing through the lens of total anarchy, like meaning, okay, you literally post all of the data and then your rollup nodes, you know, execute after the data is published on the L1, which of course is not very practical today because it would mean that you're quite slow, which is not what you want. But like base preconfirmations, is this like a sort of almost like a subnet of Ethereum or something, like another network that you directly sync from when you sync your rollup node?
Not really. So how it works, how deep should I go into the weeds here?
You can go, you know, like, yeah, I'm here to learn as well.
Well, I'll work you through the flow. So you have a validator that sends a delegation message to your I'm going to use the terminology gateway because that's the most common terminology. Sends a delegation message to a gateway, and that says that this gateway can offer commits on my behalf, and that goes through the relay, and the builder also has access to that, so they can see the commitment to know that gateway is now can offer commitments for a block that in the future. So with Ethereum epochs, you can look, there's a look ahead of 32 blocks. So if there's one validator that's signed up to participate in that future epoch, they can start offering pre-confirmations as soon as that epoch is revealed. So the flow is validator delegates to a gateway. A gateway has a delegation. This is essentially just a message that has like this cascade of signatures that allow you to slash the L1 validator if those commitments aren't upheld. And so what happens is that this gateway looks very much like a RPC node in the like monolithic gateway architecture. And this is like the phase one, which is what Tycho is doing with Gattaca and Chainbound. And this RPC node, which is also can offer pre-confirmations, that's what users are sending transactions to. In practice, this would be through like a node network with a sequencer. It looks very much like a centralized sequencer, it essentially is. But there's a new transaction type that has a signed commitment. So a user can send a transaction to the gateway, it gets confirmed, they get the response, and that response has some additional metadata that has that signed commitment. If then that transaction isn't held isn't submitted on the L1 as promised, you can then slash them. And now your question about this additional network, it's expected that this gateway would then offer the P2P. So it would offer the service to broadcast these state updates to the rest of the network, or just broadcast the block once it's completed so that the rest of the network can see it. But that gateway also has to submit it to the DA. So there's kind of like two layers here. You submit it to the DA. You also broadcast it to nodes. If nodes don't want to trust your broadcast directly, and they don't trust all of and you're not getting in each individual commitment, then they can wait for the DA and then interpret the DA. So it really just depends on the risk appetite you have as your node, or for whatever application you're interpreting blocks for.
Yeah. So I think then, like, maybe I misphrased my question a little bit, but this is like essentially how I thought about it. Like, there is the sort of soft, the confirmed, the pre-confirmed state, right? Like, this is mostly like held by like a gateway, I would suppose, and you can of course sync from that gateway via P2P, but there's some trust in that gateway, I suppose. Or
yeah, like, as a user submitting a transaction, you've got better security than you do today, better assurances, because it's economically secured, because you've got this slashing right. However, if you're another node in the network and you're just consuming the blocks the gateway's submitting, or like propagating, or transactions, if they're just propagating like frags, which is what Gelato calls it, there is a trust assumption there. Unless, and I'm not sure about this, unless the frag design actually has every single signed commitment in it, then you're not just trusting the gateway, you're trusting the validator, because they will also be slashed if those signed commitments aren't handled. However, and not a lot of caveats, you're not the one that can slash them, only the user can slash them. So you don't have, like, it's nowhere near as good as that one finalization, in summary.
Yeah, but you essentially have this this pre-confirmed state, which nowadays you already have on a centralized sequencer, right? But the difference is there's some slashing commitment in some scenarios that could be triggered. And the other difference is that these commitments, at some point at least, are issued by L1 validators, which opens up the potential for composability with the L1. But we're not sure yet how bullish that actually is, this in composability or not. Yeah,
that's a fair assessment. Yeah.
All right, gotcha, cool. So there's like a roadmap here, right? All right, so then let's talk a bit about, you mentioned already that you are optimistic. You are in L2, right? If you want to be very strict, if you are a ZK, you're probably a Validium right now, or an Optimium, I suppose. Yes. So I hate this word Optimium. It's so bad.
It's the worst. I just hate that there's like 6 different definitions for the different flavors of L2s. So I just use L2 now.
Yes, it's if you want to be an L2 Karen, then you are an Optimium. So
would you just call it the entire L2 beat Karens?
I mean, no, like
I think you might.
I'm a power user, but like Optimium, like we need to find a better word. I think we can all agree.
If there was one word for Optimium and Validium in one, I'd be marginally happier.
Yep. Yeah. So actually, I mean, I'm super bullish on ZK. We have been burned by ZK by being a bit too early back in the day with the Polygon CDK. It was cost us a lot of time and effort and didn't really go somewhere back then. But I think we were just too early, and that's maybe this year, maybe next year is finally the time. For your roadmap, like right now, like, I mean, I suppose that must have been one of the biggest lifts for you, is actually developing a fraud-proof system for your VM. Was that like a big lift or not so much?
No, I should have mentioned this at the start. So I'll clarify our stack. So we're using Reth as a dependency in our nodes. We use a lot of Reth tech. We have our own block building pipeline. We use a lot of Reth types, and we're using Revim under the hood. And then for the consensus layer, we are using the OP stack. We've got our own fork of the OP stack. We were modified for performance, but we're still using OP's fraud proofs. And that's the plan. Like, OP's done a brilliant job of building great open source tech. We're going to use that until ZK alternatives are available, or we build out our own with like the ZK providers that are available.
Cool. All right. Any major unlocks that you see from ZK, like for Rise? Are you bullish on, I don't know, ZK interop bridging, What's
Definitely.
the...
Yeah, it improves the security, but also allows much faster interop between chains, and it unlocks our native bridge. So our native bridge just isn't all that great in the interim, and we really want to reduce that window, and the best way to do that is with ZK. So yeah, super excited to get that going. And I was super bearish. I thought that if you asked me in January, I would have said we're 2-3 years away. But it's keep coming increasingly more likely that this will be possible next year.
Yeah, cool. All right. Yeah, actually, I have a piece coming out. I had it shelved for like 2 months now. I don't think it's becoming stale, but essentially it's about like talking about L2Beat, about updating the metrics a little bit away from just green slices and words like optimium to actually like what I call an Ethereum settlement score, where you have a weighting of empirical data, like, okay, how is the chain actually being used, right? Like, is the native bridge being used, or is all of the TVS in the chain coming from external bridge providers, right? Or is natively issued on the chain? And actually one of the biggest weightings we have, I think the biggest weighting we have is essentially you should become based if you want to have a high score on Ethereum settlement. And that's because of the forced inclusion, like the atomic inclusion mechanism. I think that is important there. And ZK is another big weight, because that's essentially bringing, like you mentioned earlier, like that's bringing the forced inclusion latency down. Like I think hand in hand, having base sequencing and ZK is like, I think what Justin calls an ultrasound rollup. So I think if you want to be close to Ethereum, then this Ethereum settlement score, which is also, by the way, taking in the L2, a lot from L2Beat, like the stages and so on. I will publish that soon. But it sounds like Rise, you guys really like, you want to be like the future of Ethereum sort of type.
One day we'd like to do that, yeah. Because, and correct me if I'm wrong, where you're going with that is that you can essentially get single block bridging between L1 and L2, because we've got this like delayed proving. So you can submit it, like if we've got the proving within 8 seconds, you're able to send transactions directly to Ethereum within a single block, because the proof will be there fast enough and you're using base sequencing. So yeah, that's the end state. Ultimately, I think that's the likely end state for all rollups, in my opinion, unless they spin up their own decentralized validator network.
Yes. So I think like solving bridging, making it trustless, essentially was the core motivation behind L2 rollups and so on, right? Because the multi-chain world happened, and then we saw all these sidechain bridges getting hacked left and right. And then the Ethereum community sort of came and said, okay, maybe there's a better way of doing this with a layered architecture and this canonical bridge. We're now in this weird evolutionary part where it's like, no one is using these canonical bridges really. Like they're all usually, like you're minting USDC or USDT with layer 0 or whatever, CCDP, whatever it is. Actually, I think this is an interesting question for like why you care even about, as a rollup, like why do you care about being a layer 2 and why do you care about the native bridge? Is I think also because you don't just want to build like a HyperLiquid core like perp DEX, right? Like you don't just want USDC to be collateral and that's pretty much it, right? Like you have other plans for Rise. Tell us a bit more like now about Rise's GTM. I know you definitely have a focus on CLOBs that's currently on vogue, but yeah, it's probably more than that, right? Like, so how do you see Rise play within this space of CLOB app chains like HyperLiquid Core? I mean, we know they have an Hyper EVM now as well. Like maybe they just started from the core and you start from the EVM side, but also Hibachi. And we might interview some of these players together, you and I, actually soon. So Hibachi, Bullet, like these sort of CLOB perp DEX chains. Yeah, where does Rise fit in as a platform play? And do you want to go beyond CLOBs? Do you also care about spot, not just perp? What is the dream for Rise, the platform?
Yeah, look, I think in today's market, if you're launching a generalized EVM chain or any generalized chain, to be honest, it's such a competitive market that you can't, in my opinion, you can't go broad. You've got to pick an opportunity and zero in on that. Ideally, that opportunity leans to your strengths. So that's why we are so focused on CLOBs. It's also personally where my interests lie, so, and I have influence on this decision. So I see CLOBs as a massive opportunity. Like there's clear PMF. There's one player in the market today that's the clearly proven to the rest of the space that you can build a on-chain exchange that can compete with infrastructure that's offered in the Web2 landscape and compete with Binance. And I think secondary is to compete with other exchanges as well beyond that. And that's exciting. Like there's just so much growth in that space. The idea of bringing equities perps to the world via a fully on-chain exchange that's built on Ethereum using ZK tech, that's kind of mind-blowing, and that's what we're inspired to do. So we're very focused on CLOBs and DeFi. I see CLOBs as being, or like limit order books, as being the potential for a very high PMF or high revenue application that can help fuel the rest of the ecosystem. And like where we started at, composability is what I'm really interested in, this ability to build applications on top of one another in a purely permissionless manner and just innovate and just let the product speak for itself, like we saw in the early DeFi days. But we can't get there unless we have enough activity on the chain to give that opportunity to people. And we're seeing it on Hype EVM at the moment. That ecosystem is essentially funded by, or like propped up by Hypercore. A high PMF, high quality product is like giving value to this Hyper EVM. And so that's the direction we're taking. So very, very focused on CLOBs. We expect to see a very successful CLOB on Rise, and that's going to help fuel the broader DeFi ecosystem. And one of the lenses I look at is I see CLOBs as the primitive that will unlock a lot of new use cases that, like we saw with Uniswap, like RoboVault, for instance, was a money Lego that plugged into Aave as well as UniV3. We're going to see things like that can be built on top of CLOBs, like I mentioned previously, a fully on-chain Athena, or using like a CLOB option strategy to hedge an AMM position. It's just kind of the design space there really blows up. So yeah, to answer your question, CLOBs are one of the verticals we're super focused on, and we're going to leverage that to build a thriving DeFi ecosystem. There are a lot of opportunities outside of DeFi and essentially model books for high performance, low latency chains, particularly gaming and social fi. I think they're really interesting, but it doesn't make sense to compete for block space with gaming and DeFi. I see that if that's the case, then like it only makes sense if you're leveraging some of those applications and synchronous composability matter. So I buy into the thesis that you can't run the global on-chain network on a single machine, and that you're going to need multiple machines. So yeah, a bit of a roundabout way to get around to saying CLOBs are the focus. We're going to nail that particular vertical.
All right, so let's dig a little bit into your positioning and also counter positioning vis-a-vis your closest competitors. First of all, I think we're all aware now that you're very technical minded. I think Rise in general is a testament to that you guys are all about the tech, right, as well, for sure. And that's one angle to approach things. So let me try and summarize probably how you think about your strategic positioning against someone like HyperLiquid, who would probably be one of your main competitors. Like, I mean, ultimately you probably also want to be a Binance killer or whatnot, but like right now everybody is probably the HyperLiquid killer, although PR wise you probably don't want to say that, or you do, I don't know. Positioning wise, like from a technical standpoint, you guys are very efficient, because one of the key things that HyperLiquid needs and is core to it is decentralization, right? We know that actually that might not be their strongest suit because it's still closed source. We don't know who the validators are. Are they all Jeff, right? But it seems to be very important for them right now. Maybe people underestimate the importance because we are in a very pro-crypto Trump administration. But if we all remember like how the years were before Trump, like it was very different, the environment. So right, like I mean, even today, like I don't even think like US Americans they're not even able to trade on HyperLiquid. I think right, like so even today you have like this issue of centralization and so on. I mean, that's on the front end level, but ultimately speaking, like decentralization, censorship resistance, permissionless markets, permissionless capital formation, that seems to be why crypto is cool. And I mean, that seems to be what HyperLiquid is building toward, what you guys are building toward. And there, like, I think one of the key aspects is you get a ton of performance, but and you get a ton of decentralization and you buy this at a way cheaper cost than the HyperLiquid validator network. Is that like, would you say that's the crux of one of the strong positionings of Rise?
Yeah, look, that was a more coherent description than I laid out, to be honest. Yeah, look, the only things I'd really zero in on is the composability component as well. I think is another position. Like they have a lot of friction, so there's opportunity there. But yeah, we consider ourselves a performance arm of Ethereum, and like you go to Ethereum for deep liquidity, you go to Ethereum for yield farming. You can deploy hundreds of millions of dollars there. That won't be the case on Rise, at least initially. Rise will be for high performance activity, and that's really how we see it. And we want to maintain the values of Ethereum, not just values, but the features of Ethereum, and that is liveness and censorship resistance, which is extremely important long term for a product like a global exchange. So yeah, I think it was a very sound description.
All right. So essentially, what you have going for you is you get arguably a higher, you definitely get a higher degree of decentralization on your roadmap for way less of the cost, probably because of the efficiency of a based rollup design. And you have the other thing is you have composability built in from the start because you're all in on EVM versus HyperLiquid. We know have HyperLiquid core, and then they're trying to have sort of strap this hyper EVM on top of that, which so far looks like it's pretty difficult. Yeah, actually, like I mean, people love to criticize EVM as something that is containing the potential of the space in terms of performance, but it seems like you're very confident that actually you can go all in on EVM and not have too many bad trade-offs there. Yeah,
absolutely. We tested that theory that the EVM was a bottleneck and found that it's not the bottleneck. There are caveats, but broadly speaking, there's other bottlenecks like state access and just reading and writing from databases fast enough that play a bigger impact than the actual VM itself. So yeah, I'd agree. So it's reduced cost, composability thanks to EVM from day one. Everything's going to be EVM. We get all the tooling that you benefit from the EVM. And then decentralization, I'd argue that we'd get stronger liveness and censorship resistance guarantees.
Yeah, and you might have your own network effects a bit because you have multiple applications building on top of your infrastructure that can share in the costs and essentially produce revenue for the platform to be improved over time. So versus HyperLiquid is a bit like there's this enshrined app, right? And it's the king made app, and there's no competition between like perp dex models potentially and so on. It's like, would you say that's another angle, or?
It is an interesting one that you create a competitive landscape for CLOBs. However, the one challenge is that you'd also fight for fragmented liquidity. So it's the Uniswap, SushiSwap challenge, or PancakeSwap, sorry. Oh, sorry, no, yeah, SushiSwap and Uniswap. So yeah, we are building Rise to be like a competitive hotbed for CLOBs to to compete, and the CLOBs that deliver on distribution and product are going to be the ones that win. And yeah, that's the angle I'm most interested about. And it also means that if there is a CLOB that becomes complacent because of composability, that then the other incumbents can come, sorry, not incumbents, but other startups can come and try and compete quite seamlessly.
Would you say that, like, interesting that you mentioned fragmentation again for a problem, as a problem for Rise? Like, let's say you have two CLOBs on Rise. From the user's trade execution perspective, can't you easily split the trade amongst both of them, both order books?
Yeah, absolutely. For you essentially aggregate those trades. You can do that on chain or off chain. So the difference between fragmentation on a synchronous network is far less than fragmentation between two networks. So honestly, it's almost not worth mentioning.
Cool. All right. So like that's like the technical aspect, but as we know, product is very important. I'm sure you guys will support great builders there. Maybe build something yourself at some point to bootstrap, but definitely you want to be neutral, right? Like that's the platform play. Yeah, and then you have some trading experience yourself. Of course, HyperLiquid success is hard to replicate because there's a lot of path dependency in how like the airdrop went and this and that, right? But like other than the tech, where do you feel like where do you have strategies like for or experience for like essentially getting people on chain these days? Because like as you said yourself, like it's insane how many general purpose chains there are and launching, right? Like we also have Mega ETH, Mainnet still coming and this and that. Yeah, like GTM wise, like I'm sure this is the hardest nut to crack for you. But yeah, do you have any thoughts there?
Yeah, look, this is the hottest discussion within Rise about the direction here, and it's been evolving for the past 12 months. We've clearly taken a different approach to other teams that we have been very product focused. I'm a big believer in like pick something simple and just do it better than anyone else, and that's the direction we've taken, and then we're using that to onboard some really strong teams. So rather than taking the approach where you start with mindshare, you leverage that mindshare to onboard builders, and then you use that to build hype for a big mainnet. We're taking a more like traditional Web2 approach to some degree, where we're very focused on the product. We leverage the product as well as relationships to onboard very strong teams, and then we'll use those teams to help share this story about why this is important, and then go to mainnet with an ecosystem that is strong and has the right pieces in place, so that is a fully it has all the primitives in place, and it has some really interesting apps that are targeting very specific distribution angles. And there's something that we talk about with teams quite a lot, and that is that what we see in crypto today is in the innovation curve, we're just at the early adopters. So this is this small segment in the curve the innovators prior to the early adopters. I don't think we've even touched on the early adopters. We're still on the innovators. And in my opinion, that chasm will be user experience. That it will be the innovators that are willing to use MetaMask, willing to deal with seed phrases. But when we go to this early adopters phase, they're going to expect a Web2 like experience. And so I think that we'll start to see a clear divide between typical DeFi apps that use MetaMask, very familiar experience for people who are on chain. People who are off chain, it's near impossible for them to use, to mobile first applications, or applications that have really smooth on-ramps, gasless transactions, session tokens, that kind of thing. So we're promoting that quite heavily within Rise, and we've got the tech to support it. Our team is mostly application builders, so we know what it takes to actually build this out. So yeah, I think it's really it's hard to say what Rise's go-to-market strategy is directly. It's quite broad, but we're really drilling in on the applications building on Rise and helping them build out their go-to-market strategy, looking for opportunities around the world where there's a a reasonable customer acquisition cost for what you expect the lifetime value of that customer to be, and really just like zeroing in on that and doing it really effectively, rather than just doing this spray and pray where you dump tokens and on the community and you get a lot of hype for a short period and then it disappears. I think we've seen too much of that in the past 12 to 18 months. We don't want to follow that playbook. We want to try something different.
Yeah, gotcha. And what like are some of the things that you are very excited about, like that are uniquely enabled by Rise Chain in the future, and like decentralized, censorship resistant infrastructure, more generally speaking, like you know, the I guess dirty word is a regulatory arbitrage is like interesting for trading assets globally, permissionless markets and so on. But yeah, so like ultimately, do you hope to find like some degen builders like who will just create synthetic perps or whatnot, or do you also have an institutional play? Like who are the builders? Like you mentioned, we're now with the innovators, but who are these early adopters that you want to address with your infrastructure?
I think it's important to lean into your strengths, and our strengths are with DeFi builders. That's what we have the most experience with. That's where our deepest networks are. So what inspires me is building what we've seen off-chain completely on-chain, and that being the catalyst that unlocks a lot more. Like there's a big path dependency here, and this is something that the Ethereum community has essentially acknowledged in the past 6 months, that you have to have a product focus before you can get all these other benefits. And that's really where I'm looking, that if we can nail fully on-chain, fully composable CLOB that maintains Ethereum values, that unlocks a wealth of opportunity for the degen builders to build really interesting applications and innovate. And I don't know what that means, but there's something deep in me that knows that there's some really interesting applications that will come out of that design space that are built on top of this traction of a Binance-like product that's fully on-chain, fully composable, and people are going to get really creative.
Cool. All right. Can't wait. So I guess let's finish. Let's wrap it up here with when Mainnet. When is it happening?
I can't say specifics publicly, but as soon as possible, we want to get it. We want to get it live. We want to get the people. We want the builders to start testing out their product with real users and real assets on chain. So yeah, soon.
Cool. All right. Thanks a lot, Sam. That was very insightful. I love doing these deep dives. I mean, I'm sure the listeners learned something. I definitely did. So super happy for you to be on here and teach us something, and to dive deep into the weeds of what you guys are building and the base sequencing as a concept and much more.
Fantastic, Louis. Appreciate you having me on. It's been fun.
Thanks.